No graph is neutral. No one presents a graph without trying to influence you in some way. Any graph is a representation of what the author thinks is true or wants you to think is true. The author may think their graph is accurate and without bias. Why then are they showing it to you? No one ever said, "Hey guys, let's draw a graph. It'll be fun." The three most common graph types are pie chart, bar chart, and line graph. Everyone has seen many versions of each, even if they didn't notice the type at the time. A pie chart is a circle with slices representing categories. The sizes of the slices correspond to the proportion of the whole the category represents. There is no natural ordering of the categories, and slice colors are arbitrary. The category name and amount are usually shown on the slices. This pie chart supposedly shows who gets what percent of the price of a gallon of gasoline. I don't know if the proportions are accurate, but that's a problem for another time. This pie chart will do for my purposes. A bar chart shows frequency by the heights in vertical bar graphs or lengths in a horizontal bar graph. The y-axis is the amount or percentage in a category. The x-axis shows the category names. There is no natural ordering to the categories. For example, the categories on the bar chart on the left are food type. The categories could be arranged alphabetically, by number of letters in a category name, or by which food you like best. A Pareto chart is a specific type of bar chart that orders categories from largest to smallest. A Pareto chart is typically used in quality control to identify sources of defects in manufacturing. There are many other applications, usually intended to show the order of problems that should be addressed. A histogram is a bar chart with ordered categories. This histogram shows the frequency of houses by dollar value, with the value expressed as a range of hundreds of thousands of dollars. Histograms are commonly used in statistics to show a distribution of values. A line graph shows a progression across time or another dimension, such as elevation or temperature. The x-axis has a natural order, and the y-axis is frequency or percentage. This graph is from the Roanoke Times and shows the revenue change by year for Freight Car America from 2006 to 2010. Any of the graph types can be used to misrepresent information. The author may or may not have intended to fudge the truth, but usually a misleading graph is intentional. Here is the pie chart shown previously that shows the percent of the cost of a gallon of gasoline attributed to each stage of production or sale. From this pie chart, it is clear that the refinery margin is the largest category and state sales tax is the smallest. A pie chart can be rotated to emphasize a category. The category at the front looks larger than it actually is. This is not a misrepresentation of data. The data is still there, showing the category names and percentages for all to see. This is a way, however, to take advantage of your perception of the chart. As Obi-Wan Kenobi said, "What I told you is true from a particular point of view." Or we can change the colors and stretch out the x-axis. The original rotated chart is in the top right for comparison. Another way is to remove the percentages from the chart, leaving only the labels. Now the small categories loom large, with no values to confuse the issue. Another way is to rotate and explode the chart. The dealer's margin now looks like the single largest portion of the cost of gasoline. Now, you ask, why would anyone do such strange things to an innocent pie chart? If you look at newspapers, magazines, or television ads, you can find an example of your own. I have a few favorites. Here is Steve Jobs showing how large the iPhone market is as a percentage of the whole. Looking at his pie chart, the 19.5% iPhone share stands out. The chart is tilted backward slightly to make the lower portion stand out. The iPhone slice is separated and pulled forward, and the vivid green color makes it stand out. The iPhone slice is clearly smaller than the blue slice at 39%, but the color difference makes the large blue slice fade into the background. Also, the 21.2% category in the upper left is larger than the iPhone's share, 19.5%, but it sure doesn't look like it. This pie chart is well known as an example of lying with the pie chart. Search on Steve Jobs pie chart for more examples. Mr. Jobs isn't the only pie chart manipulator. There are dozens of examples from many different sources. This pie chart is from an education publication. It shows something, but I don't know what that is. This pie chart from the 2012 presidential election is even better. This is another famously ridiculous chart. The percentages add to 213%. Fox News is a dependable source of misleading graphs and charts. Even an absolutely correct chart can become unreadable. This chart shows the population of Turkey by city. Bar charts are another fruitful area to misrepresent information. This bar chart shows the number of people who prefer a certain snack food. Hot dogs are the clear winner. This is the most basic and common type of misrepresentation in a bar graph. The y-axis for frequency begins at 930. The differences between the food types stand out. Here is the same information with the y-axis starting at 0. Hot dogs are still in the lead, but the difference with pizza and hamburgers is very small. This chart from Fox News purports to show the large effect of the expiration of Bush tax cuts. In the original bar chart, the y-axis begins at 3.4%. The after-tax right-hand column appears 5 or 6 times larger than the before-tax left-hand column. Starting the y-axis at 0 shows a different situation. Another very subtle difference is the coloring of the bars. Low on both bars, the color is dark. The taller bar color is brighter at the top, making it stand out even more. Other common ways are to use the x-axis to restrict the range of possible data, leaving out whole sections, or group data by different class widths. All have been done. One way to misrepresent a bar graph without manipulating either the x or y-axis is to use 2 or 3-dimensional objects instead of equal width bars. This chart shows the amount of trash per household over time. There is a clear increase over time, but the 2-dimensional bars make the differences look larger. Three-dimensional bars are even more misleading. But we don't need to restrict ourselves to using 2- or 3-dimensional bars. We can decorate the bars to improve the presentation. The young lady above the 56% bar looks very alluring, and your eyes are drawn to her first. This works on both men and women, so don't complain. She also appears larger, even though by measurement there is no difference in height or width of any of the three figures. Swapping the pensive young man for the alluring young woman de-emphasizes the 56% category and changes the impression of the graph. Which bar did you look at first? Line graphs typically show change over time. This graph from the Roanoke Times shows the loss of manufacturing jobs in the Roanoke metro area from 1990 to 2011. Clearly, there was a steep decrease in manufacturing jobs over that time period. The 10-year increments are correctly represented. The y-axis, however, starts at 14,000. This graph shows the y-axis extended to 0. There is still a decline in manufacturing jobs, but the decrease is not as large as the original graph implies. But wait, there's more. The original graph was one of two stacked together exactly as they appear here. The top graph shows the decrease in Freight Car America revenue, a business in Roanoke, Virginia. The bottom graph shows the decrease in manufacturing jobs in the Roanoke metro area. At first glance, it appears that the revenue decline of Freight Car America is responsible for the decline in manufacturing jobs, or at least that the two lines move together. The two lines fit together nicely, even ignoring the y-axis trick of the manufacturing jobs graph. But here's the more. The x-axis of the revenue graph extends from 2006 to 2010. The manufacturing job graph starts at 1990 and extends to 2012. This is the two graphs together on the same x-axis with the y-axis for the manufacturing jobs extended to 0. The revenue reduction for Freight Car America does correspond with the decrease in manufacturing jobs from 2000 to 2012. But manufacturing jobs were on a decline long before 2005. Also, the y-axis of each graph is measured differently. One is revenue, the other is jobs. The graphs compare apples and oranges. Other than the years on the x-axis, the two graphs have nothing in common. There are many ways to misrepresent information with line graphs, but it's hard to beat this one. So we'll move on. A map is a type of chart and can be manipulated just as easily. In fact, maps are a rich source of misinformation. This map hangs in many classrooms across the United States, and it's probably the first world map you saw. The map is a transverse Mercator projection of the Earth. Imagine wrapping a flat sheet of paper around the Earth with the open ends facing left and right. Now stand at the center of the Earth and project a line from the center to features on the Earth. That's the transverse Mercator projection. The transverse Mercator projection is a sailor's map. To sail from the southern tip of Greenland to Senegal on the African coast, You would draw a straight line between the points and measure the bearing of the line. Let's pretend it's south 20 degrees east. Set your compass for south 20 east and sail on. Even though the Earth is round, the direction on the map is correct. No matter where you start or end, the direction will be correct. While direction is correct, shape and size are distorted. Greenland looks very large, larger than Australia. Australia is really 3½ times larger than Greenland. North America, the United States, Mexico, and Canada, appears at least twice as large as South America. In fact, South America is 3/4 the size of North America and 3 times larger than the United States, including Alaska. Before we go any further, write down the names of the continents. Spelling doesn't count. The last question was a trick. I didn't want to tip you off to the real question. How many continents are there? If you are like most people in the United States, your list of continents is Africa, Antarctica, Asia, Australia, Europe, North America, and South America. That's 7 continents. But what makes a continent? We can separate Africa, Antarctica, Australia, North America, and South America from each other, because there is only a small connection to another continent, or no connection in the case of Australia and Antarctica. But what about Asia and Europe? Where does one end and the other begin? The continents of Europe and Asia are not separate. It's one big piece. Why make 2 pieces out of one? The maps have always been correct, but you've been misled by names. The original distinction between Europe and Asia was made by the Greeks and Romans. Europe was us, and Asia was them. There was plenty of time to correct the error, but the United States was primarily colonized by Europeans. The continent of Asia was still them. They weren't as civilized, or they spoke odd-sounding languages, or they had different customs, or they just didn't look like us. The names of the continents maintained an artificial distinction. Fortunately, Eurasia is becoming the name of choice for the entire landmass. It may still be us or them, but we don't use a continental definition to make the separation. Many other projections of the Earth have been made to correctly represent some feature. The Peters projection shows correct area, but not shape. The Robinson projection, now in wide use, is a compromise between size and shape. But the projection used, or the continent definitions, are not the only misrepresentations. Who decided north was up and south was down? I don't think South America, Africa, and Australia got a vote. But that's not the final misrepresentation. Look again at the Mercator projection. It's useful for all its faults, but it has one characteristic in common with the Robinson projection and Peters projection. The one characteristic is, where is the middle? The Atlantic Ocean is at the center of most maps you will see. North and South America, Europe, and Africa are toward the center. China and Australia are at the right-hand edge of the map, and Russia is split on both sides. We usually put the most important parts in the middle. This is a Chinese map of the world. China is in the middle, and North America, South America, and Africa are on the edges. Now China is important. We are on the edge. Map distortion or misrepresentation are not always bad. The early London Underground maps showed the correct geographical route through the city. The stations and routes were simply overlaid on a map of the city streets. This map is accurate, but it's hard to use. Charles Beck created the type of subway map we see today. He realized the passengers didn't care what street they were under or even which way they were going. The stations are equidistant, and all the twists and turns of the street maps are removed. You start here and end there, with not much scenery along the way. Mr. Beck's misrepresentation is used for subway maps around the world. Keep in mind that every graph, map, or picture is someone's version of the truth. Misrepresentation may not be intentional or even consciously chosen, but there was a reason the graph was created. Your job is to find that reason and how it affects the graph presentation.